Physicists say that the universe began in an event known as the Big Bang, approximately 13.7 billion years ago. This event marks the beginning of everything we know in the universe, an extraordinary explosion that led to all matter, energy, and existence itself. The theory of the Big Bang has long been the dominant scientific explanation for the origin and evolution of the universe. It describes a moment when the universe rapidly expanded from a hot, dense state into the vast cosmos we observe today. However, while this theory provides a framework for understanding the universe's early development, it leaves many questions unanswered. One of the most fascinating questions is what triggered this immense explosion. If the Big Bang was the beginning of everything, what caused it, and why did it happen? These questions have fueled the curiosity of scientists for decades, leading to extensive research, debate, and observation in the quest to understand the origins of our universe. Over time, scientists have continued to explore and study both the science and history of our universe. The Big Bang Theory has been the most widely accepted explanation for everything we observe, from the distribution of galaxies to the cosmic microwave background radiation, the faint glow of the Big Bang itself. Countless investigations have been conducted over the years, with thousands of scientists around the world dedicating their careers to uncovering the mysteries of the cosmos. The data gathered from these studies has consistently supported the Big Bang Theory as the leading model for the evolution of the universe. According to the theory, a mysterious force known as dark energy plays a crucial role in the ongoing expansion of the universe. Dark energy, which is believed to be far more abundant than the energy found within galaxies, acts as a repulsive force that causes the universe to expand at an accelerating rate, counteracting the gravitational forces that would normally pull everything back together. The field of cosmology has advanced significantly over time. As technology progresses and we develop new tools for observation and experimentation, our understanding of the universe continues to evolve. Many things once accepted as absolute truths have been proven incomplete, or even entirely wrong, as new evidence emerges. A prominent physicist, Michio Kaku, has pointed out that even the theory of the Big Bang, long considered the foundation of cosmology, is now facing challenges. Recently, observations made by the James Webb Space Telescope, JWST, have sparked significant debate among scientists. The telescope has detected 750 new galaxies that appear vastly different from what previous models predicted. These startling discoveries are compelling scientists to reevaluate established theories and delve deeper into the mysteries of the universe. As these discoveries unfold, they have the potential to reshape our understanding of the universe. The James Webb Space Telescope, with its cutting-edge technology, is revolutionizing the way we perceive the cosmos. Its findings have pushed the boundaries of our knowledge, particularly regarding the formation and evolution of galaxies. The telescope has captured images of many galaxies that defy previous assumptions, leading to a new perspective on cosmic evolution. These discoveries are exciting not only because of what they reveal, but also because they challenge long-held beliefs about the Big Bang. For those eager to stay informed about the latest developments in astronomy and cosmology, the images and data coming from JWST offer a fascinating glimpse into the farthest reaches of space. The newly discovered galaxies, with their stunning structures and surprising characteristics, are prompting experts to revisit their theories and explore new possibilities regarding the origins of the universe. The James Webb Space Telescope has provided some of the most breathtaking images of galaxies ever captured. In a single image, one can see countless galaxies clustered together, their beauty and vastness astonishing to the average person. However, for professionals and experts, these images are not just visually striking. They are also profoundly disruptive. The galaxies captured by JWST appear radically different from what scientists had predicted based on the Big Bang model. They seem smaller, more diverse, and surprisingly old, raising questions about the accuracy of existing cosmological theories. These unexpected observations are causing waves of concern within the scientific community, with some experts even using the word panic to describe the reactions to these new findings. The discrepancies between what was previously predicted and what has now been observed are forcing scientists to reconsider the fundamental assumptions of the Big Bang theory. For decades, the theory of the Big Bang has served as the primary explanation for the origin of the universe. According to this theory, approximately 13.7 billion years ago, the universe began as a single, unimaginably hot and dense point that rapidly expanded in what is commonly referred to as the Big Bang. This explosive event set into motion the formation of galaxies, stars, and planets, including our own. However, the new images captured by the James Webb Space Telescope have cast doubt on this long-accepted narrative. These images challenge the established story of the universe's beginning and have opened the door to alternative possibilities regarding how the universe came to be. The galaxies revealed in these images appear to be too small, too smooth, and too old to fit within the framework of the Big Bang theory. This suggests that the true story of the universe's origins may be far more complex than previously believed. One of the most striking aspects of the universe, as seen by the James Webb Space Telescope, is the size of these galaxies. The galaxies appear several times smaller than those observed by the Hubble Space Telescope, directly contradicting the assumptions of the Big Bang theory. According to the theory, as the universe expands, objects within it should appear larger as the distance between them increases. However, the galaxies observed by JWST are not behaving as expected. They are smaller and more compact, defying the standard model of cosmic evolution. Moreover, the smoothness of these galaxies is both surprising and puzzling. The Big Bang theory predicts that galaxies should display a high degree of irregularity in their shapes, with noticeable variations due to the turbulent processes of their formation and evolution. However, these newly observed galaxies are remarkably smooth, with far less complexity than scientists would expect for galaxies of their age. This smoothness challenges the timeline of galaxy formation and suggests that something about the standard model may need to be reconsidered. At the beginning of the universe, all matter, energy, and the building blocks of existence were packed into a single point of unimaginable density, known as a singularity. This singularity, according to the Big Bang theory, suddenly expanded in an event that led to the formation of everything we observe today: the stars, galaxies, planets, and even life itself. However, new findings from the James Webb Space Telescope, JWST, suggest that the reality of the universe's origins might be more intricate than previously thought. Challenges to the Big Bang theory. For decades, the Big Bang theory has been the dominant explanation for the universe's beginnings, supported by evidence such as cosmic microwave background radiation and the observed expansion of the universe. However, the recent JWST observations have forced scientists to reconsider key aspects of this model. One major issue is the age and structure of the newly observed galaxies. These galaxies appear to be too well-formed and too mature for their supposed age under the Big Bang timeline. Instead of finding chaotic, newly forming galaxies in the early universe, JWST has revealed fully developed galaxies that challenge conventional expectations. Another major puzzle is the existence of galaxies that are significantly smaller than expected. If the universe expanded in the way the Big Bang model predicts, galaxies should appear larger the further back in time we look. However, JWST's discoveries contradict this assumption, showing galaxies that are unexpectedly compact. Additionally, the smoothness of these galaxies contradicts expectations. The standard model predicts that early galaxies should be highly irregular, shaped by violent mergers and interactions. Instead, many galaxies observed by JWST exhibit a surprising level of uniformity and symmetry, suggesting that galaxy formation may have been much more orderly than previously believed. New theories and possibilities. These surprising findings have prompted some scientists to explore alternative explanations for the origin and evolution of the universe. Several theories are gaining attention. 1. A cyclic universe model. Some researchers propose that the universe undergoes endless cycles of expansion and contraction, meaning the Big Bang was not the absolute beginning, but rather one of many rebirths. 2. A revised Big Bang model. Some cosmologists suggest that the Big Bang may have been more complex than originally thought, possibly involving multiple expansion phases or unknown cosmic forces influencing early galaxy formation. 3. A completely new cosmological theory. If further observations continue to challenge the Big Bang theory, scientists may need to develop an entirely new framework for understanding the universe's origins. The future of cosmology. The James Webb Space Telescope has only begun its mission, and its discoveries are already shaking the foundations of modern cosmology. As more data is collected, scientists will either adjust existing models or develop new theories to explain these unexpected findings. Regardless of the outcome, one thing is certain: our understanding of the universe is evolving. What once seemed like settled science is now being re-examined, proving that science is always a journey of discovery and revision. The next few years will be crucial in determining whether the Big Bang theory needs modifications or a complete overhaul. As telescopes like JWST continue to peer deeper into space, they will help unravel the true story of our universe's origins, a story that may be even more extraordinary than we ever imagined. Peculiarity. This peculiarity addresses the beginning stage of everything, where the laws of material science, as we understand them, start to break down. In this state, matter and energy were so densely packed that their behavior became challenging to describe using regular physics. The nature of the peculiarity is established in Albert Einstein's theory of general relativity, which explains how gravity acts on massive objects. Within it, the density of matter reached an infinitely high value, creating conditions that we cannot fully comprehend or replicate with our current understanding of physics. The temperature at this moment was extreme, far surpassing anything observable in the universe today. It is within this peculiarity that the seeds of the universe were planted, containing all the mass and energy needed to create everything we see around us today. After the initial peculiarity, the universe began to grow and expand, undergoing a rapid cycle that stretched the fabric of space itself. This expansion, known as cosmic inflation, occurred at an astonishing rate, far exceeding the speed of light. During this phase, the universe expanded dramatically, smoothing out any irregularities and laying the foundation for large-scale structures such as galaxies and stars. Cosmic inflation played a critical role in shaping the universe as we know it today, homogenizing the distribution of matter and energy to ensure that the universe would be relatively uniform on a large scale. As the universe continued to expand, the rate of growth gradually slowed, leading to the development of more complex structures. Scientists have been able to observe the effects of this ongoing expansion through phenomena such as the redshift of light from distant galaxies, which indicates how the universe continues to grow and evolve over time. During the early stages of the universe's evolution, all matter was compressed into a tiny volume, creating conditions that made it impossible for stable matter to exist in its current form. However, as the universe expanded and cooled, these extreme conditions began to change, allowing particles like protons, neutrons, and electrons to form. These particles interacted with the surrounding light and energy, eventually leading to the formation of matter as we know it. This process, known as nucleosynthesis, took place within the first few moments after the Big Bang and played a crucial role in the creation of the elements that make up our universe. Interestingly, while scientists expected to see chaotic and disrupted galaxies due to various interactions in the early universe, images captured by the James Webb Space Telescope, JWST, tell a different story. Instead of observing turbulent galaxies, the telescope has revealed orderly spirals and curved structures that resemble the galaxies we see in the universe today. This challenges previous expectations that collisions and interactions were common in the early universe. Additionally, the optical illusion predicted by the expanding universe theory, in which objects should appear smaller due to cosmic expansion, also fails to hold up against these powerful observations. The galaxies captured by JWST do not appear as tiny, raising further questions about the validity of the Big Bang theory. Furthermore, the age and abundance of these galaxies challenge the idea that the universe followed a predictable path of evolution and growth. The telescope's infrared capabilities allow it to focus on the light from distant galaxies, providing insights into the ages of stars and galaxies. This has led to the discovery that many of these newly identified galaxies are much older than scientists had expected, further complicating the narrative of cosmic history. As we continue to learn more from the James Webb Space Telescope, it becomes increasingly clear that our understanding of the universe may need to be revised. The potential implications of the telescope's discoveries extend beyond rethinking the Big Bang theory. One significant aspect of this challenge is the role of dark matter and dark energy in shaping the universe. These mysterious forces may be more complex than previously understood, and JWST's findings may lead to a re-evaluation of how they fit into our broader understanding of the cosmos. We may be on the verge of discovering new aspects of the universe's origins and its ongoing development. In doing so, we might be forced to confront the possibility that the story of how everything came to be is far more complex than we have ever imagined. As the James Webb Space Telescope, JWST, continues to collect data, it provides an invaluable opportunity to refine our understanding of the universe's origins. Its extraordinary ability to observe distant galaxies in infrared light has allowed scientists to peer deeper into space than ever before. These observations are offering insights that challenge the foundations of established cosmological models, suggesting that the story of the universe's birth and evolution may not be as straightforward as previously thought. The discovery of unusually small, smooth, and surprisingly old galaxies has opened up new lines of inquiry. Some researchers are now considering whether alternative models of cosmic evolution, such as the idea of multiple Big Bangs or cycles of cosmic rebirth, might be more plausible. The notion that our universe could be part of a larger cyclical process, where the universe repeatedly expands and contracts, has been explored in some theoretical models, such as the Big Bounce theory. In this model, the current universe would be the latest phase in an endless sequence of universes, each emerging from the collapse of the previous one. This cyclical theory contrasts with the traditional one-time Big Bang model, but could provide answers to some of the inconsistencies observed by JWST. Another hypothesis being discussed is the possibility that dark matter and dark energy interact in more complex ways than previously imagined. These mysterious forces make up most of the universe's mass energy content, yet their precise nature remains elusive. If new interactions or properties of dark matter and dark energy are discovered, they could significantly alter our understanding of how the universe has evolved and why it continues to expand. Some scientists believe that the accelerating expansion of the universe, driven by dark energy, may be responsible for some of the surprising discoveries observed by JWST. Moreover, the concept of cosmic inflation may need to be reconsidered. Inflation refers to the rapid expansion of space during the first few seconds after the Big Bang, which explains the uniformity of the universe on large scales. However, some scientists have suggested that inflation may not be the sole explanation for the current distribution of galaxies. The new findings from JWST, particularly the identification of unusually small and old galaxies, may require a rethinking of how inflation unfolded and its role in shaping the universe as we know it. JWST's ability to probe the early universe has also reignited debates about the nature of the first stars and galaxies. Previous theories suggested that the first galaxies should be chaotic, with significant clustering and irregularities due to the intense gravitational forces at play during their formation. However, the smooth and ordered nature of the early galaxies observed by JWST raises the possibility that the first stars and galaxies may have formed through a more stable, less violent process than once thought.